In this video, we're going to take a look at or demonstrate how to common factor. And common factoring means to write an algebraic expression as the product of two factors by dividing out a common term or expression. We'll talk about terms really in the first few examples here, that is common to all parts of the original expression. Now I'm going to show you how to do this with numbers. I can't really think of a reason you'd have to do this with numbers, but just a numerical example at the beginning to show you how this works. So let's say you had the sum of 5 and 35. So we're going to pretend for a moment that this is an algebraic expression. And it really is, technically, because it's two things added together, two numbers. Now, the number 5 divides into both of these. So if we were going to common factor this, we could factor out or divide out a 5 from both of these. And so we would normally write the 5, the common factor is normally written in front or to the left on the left side. And so what we want in here is what you would multiply 5 to give you 5 plus 35. And so we get that by dividing each of these by that common factor 5. So we divide this 5 here at the beginning by 5. That gives you 1. So we write a 1 here. Plus, and if you divide 35 by the common factor of 5, you get 7. And so that is common factored. If we multiply this 5 or distribute the 5 into the brackets, 5 times 1 is this 5, and then plus 5 times 7 is 35. So that's how you could common factor a numerical expression. All the other examples at the bottom of the page in example 1 and example 2 are algebraic because they involve placeholders, x's, y's, a's, b's, etc. And so in the first example, it says common factor each of the following. So 4x plus 12 is the first one. Now the first thing you do is you have to decide on your common factor. So you think of, well, what divides into 4x and 12? And you actually want the largest as well. So for example, 2 goes into both of those, but you want the largest common factor. So 4 actually divides into both 4x and 12. And so the common factor would be a 4. So what we're actually going to do is we don't normally write this step, but I'm going to do it a few times here just for explanative purposes. And so the common factor is this 4 that we're dividing out, or we normally say factoring out. And so if we divide 4x by 4, then that's what's going to go at the beginning of this bracket. And of course that would be just a 1x. 12 divided by 4 would be a 3, so in the end here we'll have a 3. Now you can always check any common factor, actually, or any factoring, by expanding out your factored form, and you should get the original form. So for example, 4 times x is 4x, plus 4 times 3 would be a 12. So that does check out to equal the original 4x plus 12 expression. In B, we're going to factor the 5y squared minus 40y. And so you think, well, what divides into both these? So 5 and 40. The number 5 divides into both of those. And also, you see they both have powers of y to the first here and y squared in the second, or the first term, sorry. And so we can factor a 5y out. You cannot factor something bigger than a y out of this because there's only a single y to the first power to start with. So we're going to factor a 5y out. So the common factor is this 5y. We're dividing into both of the terms. And so if we divide 5y squared by 5y, 5 divided by 5 is 1. And so at the beginning here it would be a 1 something. And y squared divided by y the first. Remember there's actually a 1 here. And 2 minus 1 when you're dividing gives you a power of 1. So you just have y to the first or just y here. And then minus. Now 40 divided by 5 is 8. And the y's divide out completely. 1y or y to the first divided by y the first is y to the 0. Or the y's divide out and we just have actually negative 40 divided by 5, which would be a negative 8. And so that is the factored form. And again, you can check 5y times y would be 5y squared. And 5y times a negative 8 would be negative 40y. For C here, 6x to the fourth plus 9x cubed minus 15x squared. So notice that the largest common number factor that divides into these three numbers is the 3. And notice they all have powers of x. So whatever is the lowest common power of x, which would be the x squared, see this is higher, would be the common factor. So we can factor an x squared out of this, a 3x squared. You can't factor a larger power of 3 out because then there's no larger power than x squared to factor out of this term, for example. So I'm not going to write the dividing out here. So 3x squared is the common factor. So we actually divide each of these by 3x squared to get what's in the brackets here. So 6x to the fourth divided by 3x squared. Well, 6 divided by 3 is 2. And x to the fourth divided by x squared would be x squared. Remember, you subtract the exponents when you're dividing powers of the same base. So 4 minus 2 would give you a 2 for the power of the x. And so we would write a 2x squared plus, and the reason I know this is plus here is because I'm dividing a positive by a positive. That's why I know it's a plus. And so to get what's going next here, we divide this common factor into the second term. So 9 divided by 3 would be a 3, and x cubed divided by x squared would be x to the first. Again, 3 minus 2 would be a 1 here. Minus, and I know it's a minus because a negative 15 divided by positive 3 is going to be negative. So negative 15 divided by 3 would be 5. 5 in the end. And there's no x in this because x squared divided by x squared, the x squareds divide out, so we just have minus 5 in the very end. Last one here, and actually this is still common factoring, but we're gonna sort of move into another. It's still common factoring, but it's called factoring by grouping, and it's really what the second example is about. So that's what this is leading into. So notice that in this expression, it's not just 2 or 3 terms here. It's actually a 2x times this 5x minus 1 plus a 7 times another 5x minus 1. Notice what's in the two brackets are exactly the same. And so we could think of that 5x minus 1 as the common factor because it's, even though it's more than a monomial like 3x squared or 5y or 4, it's still a common factor between this part and this part. And so I'm going to factor a 5x minus 1 out. So I'm going to write this dividing 5x minus 1 here. And so when I divide out the 5x minus 1, see, those divide out, and so what's left after I divide the 5x minus 1 out is a 2x. So in the second bracket, we're going to put 2x. And when this divides out here, notice there's still a 7 here, so this would be a plus 7. So that's how the original 2x, 5x minus 1 plus 7, 5x minus 1 would factor. And again, if you expanded the original question out and expanded this out, you would get exactly the same terms. That's how you could check to make sure your factoring is correct. Okay, on to example 2. Factor each of the following by grouping. And so this is kind of where this is leading. So there's 4 terms here. And the factoring by grouping, you're going to always see an even number of terms. And it could be bigger than 4. It could be even like 6 or 8 or 10, I suppose, or even bigger than that. But you're always going to see an even number. So the idea is this. Notice that there isn't a common factor in all the terms. So for example, 3 divides into 3 and 15, but it doesn't go into negative 4ab or the negative 20b. And, well, there's actually a's in all of these, but there's no a to factor out here. And actually there's b's in both of these, but there's no b to factor out here. So there's no common factor in the entire thing. But look at the first 2 terms, and sometimes you might want to rearrange it, put it in different orders. That might make it a little more convenient. I'm going to talk about that a little bit in B here. But notice the first 2 terms. We're going to common factor the first 2 terms and the last 2 terms. And so in 3a squared plus 15a, we could factor a 3 out because 3 goes into both 3 and 15. And we could factor an a out because we got an a squared here and an a to the first. So we can factor a 3a out. And so if we factor a 3a out, 3a squared divided by 3a would just give you a. And 15a divided by 3a would give you 5. Again, you can check this. 3a times a is 3a squared. 3a times 5 is 15a. Now let's look at the last 2 terms. 4 divides into both 4 and 20. And notice that there's a b in both of these, so we can factor a b out as well. Now, because this is a negative, I'm going to factor a negative 4 out. If that was a plus 4, I would just factor a 4 out. I'll always choose the sign of that third term. And so we're going to factor a negative 4 out, b, negative 4b out. And so if I factor a negative 4b out of this term, I get a. Negative 4b out of this term, I just get a 5. Again, negative 4b times 5 would be negative 20b. Now notice that the two brackets are the same, just like the one we did in D here. And so we can factor an a plus 5 out. And so a plus 5 is our common factor. And so again, think of doing this. So when that divides out and this divides out, the other factor is going to be 3a minus 4b. And so that is how this would factor. In B, the last one here, again, 4 terms. So let's try factoring by grouping. Notice that there is no common factor in all of the terms. There's nothing that goes into all 4 of the terms. So try factoring by grouping when you see that. And so what goes into the first 2 terms? 3 goes into both 3 and 6. And notice there's an x squared in both of these. So we can factor a 3x squared out. And so if we factor a 3x squared out, we get 3x squared out of this. We get 3x squared times m plus 2n. Again, you can check 3x squared times m is 3mx squared. 3x squared times 2n would be 6nx squared. And then in the last 2 terms, there's a common factor of negative 5y. So we can factor a negative 5 out of these because that goes into both those numbers, and they both have a y in common, so that's why we can factor the y out. And so if we divide negative 5y into this, you get just an m left, and negative 5y into this, negative 10 divided by negative 5 is 2, and the y's divide out, so we're left with just an n. So again, what's in these 2 brackets are the same, so we can factor an m plus 2n out. And so we'd have m plus 2n, and the other factor would be 3x squared minus the 5y. Now, what I wanted to, one last thing here, you can actually rearrange this a bit and still end up with the same factors. So, for example, let's take exactly the same 4 terms, but let's switch the the second and third term. So, I'm going to write the negative 5my and the 6n squared. Just switch them, and so notice it gives us the same 2 factors. There's a common factor here of just m. I'll write the whole thing out. So if we factor an m out here, we would get an m out of this. There's still a 3x squared minus 5y. And you can factor a 2n out of these terms. 6 and negative 10 both divide evenly by 2, and has a common factor of n as well here. And so if we divide this by 2n, 6 divided by 2 is 3. The n divides out, but there's still the x squared. Negative 10 divided by 2 is negative 5. The n is factored out, and there's still a y. So again, these are the same, so you can factor 3x squared minus 5y out. And the other term would be m plus the 2n, which is exactly the same as this, just written in reverse order, but it would be exactly the same thing. And that's the end of the lesson.